Okay, so as we talk about function inverses, some of the things we're going to be focused on is we want to find the inverse of a function and we want to use composition to verify that the functions are inverses. But before we start with the function inverses or inverse functions, let's remember that a function is something that it's often viewed as some kind of form of a function machine. As I put some value of x into a function, I get out a the f of x, or like what would be the y equivalent, or as I have the domain, I get out the range, also referred to as the input and the output. So remember your function, for every value of x you put in, you get out a unique value of f of x. For example, if I were to put a 2 into my machine, I may get a 3 out. And the function notation of that would, not going to worry about that right now. But yeah, so putting something in and getting a unique value out is a function. An inverse function is making that relation that maps from the range to back to its domain. So being able to find this 3 and going backwards and find out that my x value was actually a 2. That is the inverse. We're mapping the range value, my range value, back to the domain. So the inverse of a function maps that range or output to a given function back to its input domain. So let's see here. So we have talked about function, and we talked about a function just a few days ago. Function notation, of course, function notation is going to fall under f of x, which is all, like I said a minute ago, is often referred to as my y value. So function notation, an example of this problem for function notation, since my x value was a 2 and my output was a 3, the function notation would be for f of 2 equals 3. Because every time that I put 2 wherever there was an x value, I had f of 2. So when I put 2 into the machine, my input, I got out a 3. So here it was, when I put a 2 in, it came out a 3. Whatever that may be. So and we'll use some more function notation in the future, but that's the inverse function notation is this thing right here. That's f of -1, or inverse function is what that stands for. So we will go over some different ways to do that. And of course, the vertical line test we covered a few days ago too, where that helps us determine if something is a function, and that is just showing that for each domain, I have a unique range. So helps us calculate the inverse of a function. So let's see, going forward, looking at a graph. Well, functions graphically are reflections, and they are going to be reflections on the graph over the, that doesn't show up very well, over the line, the imaginary line of y equals x. So that's what that line is right there. So they're reflections over that line. So if I were to draw an inverse of this, it would look something along the lines of, let's see, I have this, or I start here and I go like that, and then goodness, it's a little bit more difficult than it looks, huh? something like that is the inverse of a function. So it is reflected, the red function is a reflection over this line of the original function. So my red function, this is going to be, let's see here, black function is going to be f of x. The red function is going to be the inverse function of x. And then let's see here, if f of x and its inverse function are graphed, we put them both there on the same coordinate plane. What is their point of intersection? And it looks like their point of intersection is going to be right there. And that point is going to be 3, 3. That's their point of intersection. That's looking at an inverse function and looking to just look at the graph, what's going on, and saying, hey, it's 3, 3 is where they intersect. Now, doing it algebraically is a little more straightforward, easier not to have to graph it. But I replace, there's some steps here. When I do it, it says to find the inverses algebraically. I take step 1, and I'm going to replace f of x with y. And then I'm going to, step 2, switch x and y. Step 3, I'm going to solve for y. And then step 4, I'm just going to write it in standard inverse notation. So here I am starting with this. I am starting with f of x equals 5x. So it says if f of x equals 5x, what is the inverse of x? Right, here's my inverse function of x. So if we do the first thing, and it asks me in step 1 to replace f of x with y. So I'm going to rewrite that with y. So that is going to be y is equal to 5x. Then step 2, it reads switch x and y. So I'm going to replace this, I'm going to switch those. So it's going to be rewritten as x equals 5y. Switched them. Step 3 is I'm going to go ahead and solve for y. And in order to solve for y, I need to divide away my coefficient. And then I find out that y is going to be equal to 1/5 x. Or it says to, I'm going to go ahead and do this, y equals 1/5 x. And then step 4 says to write in standard inverse function notation. So that is going to be standard inverse function notation, and that is going to be f inverse function of x is equal to 1/5 x, and that is going to be your inverse function. That's how you solve for that algebraically. We can go ahead and do this here again. This next example right here, and it says if f of x and the inverse function of x are inverse functions of each other, and f of x equals 2x plus 5, what is the inverse function of 8? So the first thing I need to do is I'm going to have to take this function and go up to step 1, and I'm going to replace f of x with y. Oh, it's already been done, so I don't have to worry about that. The next step is I'm going to switch x and y. So, oh gosh, it hasn't been done. What the heck am I thinking? This is going to be y equals 2x plus 5. So I'm going to switch my y and my x. So it's going to be x is going to be equal to 2y plus 5. Then solve for y, so I need to isolate my y. So I'm going to subtract 5 from both sides. And that is going to equal 2y, and that is x minus 5. Then I'm going to divide by the coefficient, and y is going to be equal to x minus 5 over 2, or y is equal to 1/2 x minus 5 halves. I just converted that into simplified fractions. Then the next step is to go ahead and write in standard form, so I'm going to replace that with f of negative 1x. So it's going to be f of equals 1/2 x minus 5/2. You know, and we're only halfway done here, or a little bit more than halfway done, because you have to remember that I've come up with the inverse function, but it has asked me to find out what is the inverse function of 8. Okay, so now what they're asking me to do is, in my inverse function, I want to replace x with 8. So I'm going to say f of negative 1, 8 is going to be equal to 1/2 times 8 minus 5/2, right? That's function notation. I just went ahead and substituted in 8 for where I had an x. So the inverse function of 8 is going to be equal to 4 minus 5/2, which is going to be equal to 3/2. And if that was too fast, I'll just say f of negative 8 is equal to, in order to combine these, I need to have a common denominator, is what I did there. So 4 written as halves would be 8/2 minus 5/2, which is going to be 3/2. So the inverse of 8 is going to be 3/2. There you go. So that's my answer to that question. Going on, let's see here some additional examples. Well, we said that the inverse function, remember, is when my range maps to my domain or my y maps to my x. So in this case, in this first example, it says h of x is these 4 sets of numbers, xy, 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 xy. And then what is the inverse h of x? So here, well, in order to write the inverse, I'm just going to turn around and say, hey, the inverse of x is going to be equal to, instead of x mapping to y, what I'm going to do, remember, is going to switch my x and y. That was one of my steps, so this actually becomes negative 5 and 3, right? Reversing that. Reversing that, it's going to be negative 7 and 5. It's going to be negative 9 and 6, and negative 12 and 10. So there you go. I reversed my x and y to get my inverse function. And then it asked me, what is the inverse of this thing? Well, remember, my first step is going to be change f of x to y. So this is going to be rewritten as y equals 2x plus 3. Then they go ahead and tell me to switch the x and y. That was the next step. So there's going to be x is going to be equal to 2y plus 3. And then it tells me to solve for y. I'm going to do that by subtracting 3 from both sides. Then I'm going to divide away the coefficient. And we have y is going to be equal to 1/2 x minus 3/2. And then the last step was to put in standard inverse function notation. So there we go. And there you go, we have the inverse function. And that pretty much wraps up some of the function inverses that we were looking at in this section, and hopefully these examples are going to help.